Welcome to the 5.3 surface area of a prism section. So we're going to start with a definition, and our definition has to relate directly to our title. What is surface area? Surface area is the number of square units needed to cover all the faces of a 3D object. So think of surface area like wrapping a present. You've got this box, and you need to know how much paper it takes to cover the outside of the box. So that's what the surface area is, because you don't want any of your box visible when you give it to somebody as a gift. And it's a 3D object, so that makes sense. So when we're wrapping, we fold parts over top of the paper, so there's actually extra paper required to wrap a present. But if you were to cut just exactly the same shapes out of your wrapping paper and paste it on, how much would you need? That's one way to think of it. So it's the sum of all of the areas of all of the faces of an object. So in this case, we've got a 3x4 rectangle on the front. That's one face. The top is a 2x4 rectangle. That's another face. This right side is a 2x3 rectangle. That's a third face. Now, each of those faces has a matching face on the opposite side of the shape. So there's a front and there's a back. There's a right and there's a left. There's a top and there's a bottom. In this case, they're all the same shape and size, those matching faces. And so surface area is measured in square units, just like area of a 2D shape. We're still dealing with area. So even though it's a 3D shape, our units are still squared. So centimeters squared, meters squared, kilometers squared, units squared, however you want to measure it. Working example number 1, calculate the surface area of a right rectangular prism. So that's basically the same type of shape as this guy here, but rather than having the grid showing us how big it is, we've got markings indicating what the 3 different lengths are that are involved in creating this right rectangular prism. Now, we know from previous notes that we can create a net that will recreate this right rectangular prism. And this is one example of a net that could be used for this exact shape. It's got some markings here, 4 centimeters here, 6 centimeters here, 10 centimeters here, that help you figure out what's what. Now, in actual fact, we've got lots of lines here that are not labeled, and it probably will help to see where all of these different markings belong. So all of those pink lines that I just drew, those are all 4 centimeters long. Now, here's an orange line. These ones are all 6 centimeters long. Which leaves lastly, actually, that's not complete. We've got 10 here, 10 here, 10 here, 10 here, and 10 here. Those are 10 centimeter lengths. But I have these little wings here that aren't marked yet either. As it turns out, those are also orange. You might be able to visualize it, that if you were to fold along this line here and this line here, this flap would come up and this flap would come up. Well, this section here and this section here, these edges join each other exactly. So that's why we've got orange here and orange here, orange here, orange here, 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 and here. So that's the creation of the net. So seeing it this way might help with figuring out where we're going next, and that's calculating the area of each of the rectangles involved. So, this right rectangular prism has 6 faces, as do all right rectangular prisms. They all have 6 faces. And there are 3 different sizes to those faces. And we can see that up here. We've got orange and pink, or sorry, pink and blue, that's 1. Pink and blue, that's 2. So that's a pair. We've got blue and orange, that's 1, and blue and orange, that's another. So that's another pair. So that covers all of this central column. Then we've got orange and pink. There's two here that are matching as well. So there's three different shapes, three different sizes, and they all have pairs. So we've got front or back, which we've got 6 centimeters there and 10 centimeters here. We've got 4 centimeters by 10 centimeters. And then we've got 4 centimeters by 6 centimeters. So that color coding might help you with seeing where all these different rectangles come from. So now we just need to calculate the area of each of these and then double it because they all have pairs to create the 6 faces of our rectangular prism: front, back, left, right, top, bottom. And then we add all those numbers together. So in this case, area of a rectangle is length times width. So 10 times 6, which is 60 centimeters squared. When we double that, because there's 2 of these, that's 2 times 60, or 120 centimeters squared. This one, we've got 10 times 4, which is 40. Double that, and we have 80 centimeters squared. Next up, we've got 6 times 4, which is 24. Double that, and we have 48 centimeters squared. So now we can add these 3 numbers together to get the entire surface area of our rectangular prism. So 120 plus 80 plus 48. Well, 120 plus 80, that's 200. So 200 plus 48 is 248. So the surface area of this rectangular prism is 248 centimeters squared. Next up is a show you know. Give it a go.